Ldap, or Lightweight Directory Access Protocol, is an open industry standard protocol for accessing and maintaining directory services. When we say directory services, we're referring to something similar to a phone or email directory. It's most commonly used as a backend for authentication of accounts. The Ldap specification describes the data structure of the directory itself and defines functions for interacting with the service, like performing lookups and modifying data. You can think of a directory like a database, but with more details or attributes, describing entities within the database. The structure of an Ldap directory is a sort of tree layout and is optimized for retrieval of data more so than writing. Think of it as being similar to a phone book, being used for looking up data far more often than making modifications to that data. Directories can be hosted across lots of different Ldap servers to facilitate more rapid lookups and are kept in sync through replication of the directory. So what kind of data gets stored in a directory entry exactly? Similar to an address book, an entry for a particular user will contain information pertaining to that user account, like their first and last name, phone number, desk location, email address, login shell, and other such data. Along with object attributes, the location of an entry within the overall data structure will represent information pertaining to the objects as relationships between objects. Because Ldap uses a tree structure called a data information tree, objects will have one parent and can have one or more children that belong to the parent object. You can also think about this like a file system, with a root file system and folders under that. The folder an object belongs to will provide information about that object because of its relationship to the parent object. In Ldap language, we call these folders organizational units, or OUs. They let us group related objects into units, like people or groups, to distinguish between individual user accounts and groups that accounts can belong to. This tree structure also allows for inheritance and nesting of objects, where attributes or properties of a parent object can be inherited by children further down the tree. Now, since it's possible for entries in the directory to share attributes, there must be a unique identifier for each entry. We call this distinguished name, or DN. Coming back to our file system analogy, you can think of a DN as a full path to a file, as opposed to a file name. This is because you can have multiple files with the same file name across a file system, but the fully qualified path to the file would describe one unique file. Some of the more common operations that can be called by a client to interact with an Ldap server are bind, which is how clients authenticate to the server, start TLS, which permits a client to communicate using Ldap v3 over TLS, search, for performing lookups and retrieval of records, add, delete, modify, which are various operations to write data to the directory, and unbind, which closes the connection to the Ldap server. Now, there are many implementations of Ldap servers, like Active Directory from Microsoft and OpenLDAP for open source implementations.